the MAD, or the mean absolute deviation, you first have to find the mean of the data. So the mean of the data here for the high temperatures, we added them all up, which is 548. We divide it by 7, and we get 78.29. It did ask us around to the nearest hundredth. So the mean was 78.29. All right, going on to the next one. Let's go ahead and get that mean done right away, too. Add up all the low temperatures, divide by the 7, and we get 48.71. This is going to be more difficult. To find your mean absolute deviation, you have to find the difference between the mean and each data point. So you're going to take the 78.29 and minus 68. What would you get for that, for example? Anyone get that one? Okay, so 10.29. Then you go to your next data point, which is 74. What would you get for that one? Good. 4.29. Then you would go to your next data point, which is 76. What would you get for that one? Yep. 2.29. Okay, 2.29, and so forth. So you're going to add those all up and then divide by what? What are you going to divide by? So after you go on to the next one, then you go to 78, and you get plus 0.29, and then keep going. What would you divide by? 7. So what did you end up getting? Once you add them all up, divide by 7, what did you get for your mean absolute deviation? Did you get it? 4.9. 4.9. Or 4.90, some people might write. So your MAD is 4.9 or 4.90 what? What are we dealing with again here? Which I should have put in. Yep. Degrees. So I'm going to put degrees here, degrees here. I'm actually going to go over here and do the degrees here. Then we go over here. To find the MAD, we take whatever the mean is and subtract each data point. We have to go through all of those and subtract each data point. So for example, just starting it off, we are going to take the 48.71 and subtract 44. What would be the difference between those first two? Anyone know? Yep. Oh, anyone? Okay, sorry for the distraction. Okay. Looking up here, who can take 48.71 and minus 44? What do you get? 4.71. Go to the next one. We have 48. What's the difference? 0.71. We have another 48. Yes.
0.71.
And we're going to go through all the rest of these dots. Add them up, divide by 7, and what's the mean of all the deviations there? Did anyone get that one? That far? Did you get it?
With the math and the lows, I got 1.76.
Oh, did you tell me the 4.9? Who told me the 4.9? Was that for your high? Oh, no, you were right for the high. And you're telling me you got 1.76 for the low? Yeah, so the second one that we're working on, 1.76 is correct. So your MAD equals 1.76 degrees. When you're trying to come up with a statement, you're looking at the two MADs, the mean absolute deviation. This one is of the high temperatures, this one is of the low temperatures. I usually take the one with the lower MAD and describe it, saying what? Does anyone have an example of what they might say? Yeah.
The low temperature varies less than 5.
Yeah, because the low has a smaller mean deviation, absolute deviation, the 1.76 is smaller than the mean absolute deviation of the high temperatures. We would say that the low temperatures vary less, okay?